Hello, I'm Samuel Archibald, student founder of Stun, and today we are using the Arduino, Sparkfun rather, the Sparkfun joystick shield to read analog values into the serial monitor. So this is a introduction to both the joystick shield and the serial monitor. Just doing this video with both because they're both really simple topics and they can work together very well. So we're going to talk about this code that some of it I grabbed from Sparkfun, and then we're going to go ahead and I'll show you. Basically, I'll give you the brief breakdown of it. It should tell you how this is all working, how it's physically working on the Arduino, and how it's working in the code. So let's get started. First, we have constant integer x equals 0. So what this is saying is there is now a integer that cannot be changed, named x, that is the value of it is 0. So if you call 0, you will call a 0. Constant integer y equals 1, so that's basically saying the same thing. Whenever you call for a y, it'll be replaced with the number 1. Void setup, serial.begin 9600, starting the baud rate at 9600. Because serial, when it starts, it starts at a certain speed, and you have to set that speed, otherwise the two devices won't be able to communicate. Serial is great because it's standard, and you can use a whole bunch of different speeds, and it has a bunch of pros and cons, but anyway, baud 9600 means 9,600 bits per second. It's telling it how fast to communicate with the computer. Void loop serial.printx, and this is basically saying print the number x, and then the commas, and then a space. Serial.print analog read x. This is basically saying print whatever you read on the analog pin. So basically, there's a what's called a analog to digital converter. So you put in a voltage to one end of it, and out comes a whole bunch of bits of digital data into the Arduino. The Arduino can read anything from 0 to 5 volts, because it's 0 to 5, anyways. But it gives a number anywhere from 0 to 1024. I'm going to use two sketches today. Right now I'm showing you the one that gives you the 0 to 1024. Then we're going to go and I'll show you how to make it show voltage. So this is saying read the voltage that's on the pin X. Pin X, that goes up here to 0. So pin 0, when you're using the analog read command, means A0. So you can actually put an A in front of here to make it clear, because you know that 0 and A0 are two completely different things in the Arduino. But when you're using analog read, it only reads the analog pins. So if you put 0, it'll just read analog pin 0. If you put a digital read, then it'll only use the digital pins, and it'll just read the pin 0. Print a space, then print Y, then print the voltage on pin Y, which is A1, and then print this symbol. So this character right here is kind of special. If you print this character into a serial console, it'll actually make it so it'll go down a line. I'll show you what that does. And delay 20. So what we're going to do here is I'm actually going to take this out. Alright, I'm going to send this over. I'll show you what it's like without that N. I want to show you how that /N is important, because it's very important. Alright, so you get this. Now this is kind of unreadable, but I mean, if you can see, I'm moving the joystick around, and you can see the values are changing slightly. But it's kind of unreadable. So if you take this and do a \N, and not / \, so not the slash that you usually use on your keyboard, and you upload that. Alright, so now we open up the serial monitor. There we go. So now this is a bit more readable. Alright, so now we're going to explain a bit more about the serial monitor. So if you hit this button right here, it says serial monitor, and of course you have to be connected. You have to be connected to a serial port to use the serial monitor. So you just click that to use the serial monitor, and you can send commands through here. So if I wanted to send something to the Arduino, I can do hello, hit enter, but nothing's coming back. I'll show you more about sending commands after we do the joystick with the serial. So this is just receiving, and I'm not going to show you the joystick shield. I'll show you it towards the end, but it's just a normal shield, and you have a joystick on it. So if I move it to the, let's see. So if you move it to the, crap, disconnected. I'm trying to get accurate directions. Alright, let's close that. Alright, here we go. So now if I move it to the right, you can see that X is now 1021, which it's not supposed to be able to. Yeah, oh yeah, that's right. It goes to 1024. So yeah, that's almost 5 volts. And if I move it, normally they're both in the 520 range. If I move it to the left, it goes X equals 0, because now it's reading no voltage. If I move Y down, it goes to 0 volts. If I move it up, it goes to 1022. So that's what's happening. So basically, what's in the joystick is 2 voltage dividers. So um, there's 5 volts on one end, ground on the other, and then the middle is the read pin. So whenever you move the joystick, there's this piece inside that's moving. It's changing the resistance between ground and 5 volts. And that's changing the voltage, which then is going to the analog read pin. So if I've explained that well enough, that's how you do all this fancy stuff. But now we're going to also add button functionality. So let's go ahead and do that. Alright, so now we're going to go ahead and we're going to do the code required to make it so the button will work. So we go const int s is equivalent to 2. So now this is the digital pin, not an analog pin. So this is going to be read as digital 2 instead of the A0, A1 up here. We're also going to do, actually, you know what, we're not going to do that. We go to setup, pin mode, S is a input. Then we go ahead and alright, so it's been named as an input, but we also want a pull-up resistor. Whenever you're using a button, you always want a pull-up resistor. And the Arduino Uno, the chip that's on the Arduino, has a internal pull-up resistors. So this is how to start them. You do digital right S high. So what this is saying is it's an input, but make it high. So that turns on the internal pull-up. So now we're going to go ahead down here. I'll explain the internal pull-up more in just a second. Go down here. So now we're going to do if digital read S is equivalent to low, then button is pressed. We're going to do serial dot print button pressed. Then we can do you can do else, but I'm not going to. And I'm going to put a space right here. So we can go. I'm going to take this. I'm actually going to move it. So I do bam. There we go. So we can go here. We need a space right there. So now we should be able to upload this. Error compiling. Where is it? Selected. Where is selected? There, selected. That's something I was trying to do before I started recording. Alright, we're going to do upload. Done uploading. Serial monitor. Selected, or button pressed. Whenever I press the button, it now says button pressed. Alright, so now we have full joystick control. Button pressed and all the values. So now we're going to go ahead, close that out. Then we'll go down here. And so I'm going to explain the pull-up a bit. So whenever you have a microcontroller or something, you should never have the pins connected to nothing. It's called a pin that's floating. And when you are not pressing the button, it's actually not connected to anything. Therefore, it is floating. So what the pull-up does is make it so whenever the button is not pressed, it's actually 5 volts. So it's always 5 volts, but then when the button is pressed, the resistance in the button is less than the pull-up resistor. So then all of it will go to ground, and it'll read ground. So that will allow it to say, oh yeah, the button was just pressed. It's been pulled to ground. Alright, hey guys, one last quick note. I've said that I would show you how to turn it into a voltage, and I forgot to do that. So I'm going to show you exactly what that is, just very quickly. So the only thing you have to do is type in float voltage is equivalent to whatever your sensor value name is, and then do 5, or do 1023 divided by 5, multiply it by that. So then you can go ahead and you can take that and just, very, sorry, you take the value and you multiply it by 5 over 1023, so then you get the voltage, because it goes from 0 to 23, or 0 to 1023, and 1023 is equivalent to 5 volts on the Arduinos. So I'm going to very quickly just show you what it's like using one of the joysticks. This is just a quick side note because I forgot to do it and I said I would. Then you guys can be rid of this video. Just go ahead and just very quickly upload that. You just need to add this line right here, and you don't have to have the int right here. It can be up there with sensor value, but whatever the heck your sensor value's name, you just need to put it there and add this line, and then print out the voltage, which is this float. So done uploading. There we go. So now we should have yep, there we go. Voltage. That's very slow. There we go. So see, now the joystick, you can see how the joystick is changing the voltage. If we go all the way to the left, it's at 0 volts, and if we slowly go towards the center, goes up 1 to 2.5 volts, and we go, move to the side, it goes to 4.99 volts. So that's just how all that works. Alright guys, thank you for watching this video. Same arts while it's done. And like if you liked it, dislike if you disliked it, subscribe if you want to see more videos, and see you all next time. Bye.